So this is section C of the ionic bonding series videos, and what I want to do is I want to see what you guys can do on your own. Now I will give you some hints and tips, but I want you guys at each section, when I give you a task, to pause the video, have a go yourself, and then compare your answer to my answer. And if you've got it right, brilliant, but if you've got it wrong, to kind of reflect on it and see where you've gone wrong and correct it. Okay, so here's the hints that I'm going to give you. The first one is I want you guys to write down the formula and the equation for the reaction between calcium, which is in group 2, so here's calcium, it's in group 2, and chlorine, which is in group 1. So I want you just to use calcium, which is in group 2, and chlorine, which is in group 7, and work out the formula and the end product for calcium and chlorine. So the hints that I'm going to give you is calcium is the metal, so I'll write metal here. So calcium is the metal, it's in group 2, and chlorine is the non-metal, so I'm going to write N for non-metal just to remind me, and that is in group 7. Now what I want you guys to do is to quite simply have a go at those and see if you can work out what the formula is and what the equation is going to be. Pause the video, have a go. Okay, so this is what you should have done, guys. Calcium's in group 2, so it's going to have 2 electrons in its outer shell. That means it's going to give away 2 electrons. So if calcium's going to give away 2 electrons, it's going to throw out those 2 negative kids. It's going to have an overall charge of 2+, because it's going to have more of a positive environment now that you've kicked out those negative electrons. Now, on the other hand, chlorine is in group 7, so it's got 7 electrons on its outer shell, but it needs to add so many to make 8 in total. So how many does it need to add to make the full outer shell? It needs to add 1 electron. So what we're going to do here is we're going to add 1 electron to the chlorine. Now, if we add 1 negative electron to the chlorine, what charge does it have? Well, it has a negative charge, of course, because that negative charge is going to the chlorine. By how much is it negative? It's negative by the 1, because you've only got 1 negative charge going onto the chlorine. So the next bit is, of course, you're going to swap over the numbers. So how many calciums are you going to have? You're going to have this number here, which is 1. So you're going to have 1 calcium. How many chlorines are you going to have? Well, I'm going to take this number and swap it over here. So you're going to have 2 chlorines. So it's CaCl2. So that's the end product. So what our equation is, therefore, it is Ca plus Cl2. Again, this is a group 7 molecule, so it's diatomic. There's always going to be 2 of them. Makes CaCl2. So is it balanced? I've got 1 calcium here, 1 calcium here, 2 chlorines here, 2 chlorines here. It's balanced. Done. Now the next task is, again, I'm going to give you those hints. In fact, I'll give you a few more hints for this one. We're going to look at calcium and chlorine again, so it's the same elements, but with calcium it is in group 2, period 1, 2, 3, 4. On the other hand, chlorine is in group 1, period, so that's period 1, 2, 3, period 3, because remember, periods go across, periods make a girl go across. So what I want you to do is to draw a dot and cross diagram. Now in the last video I didn't do dot and cross, I did both crosses. It's best to do a dot and cross diagram because that'll help you to tell the difference about which electrons are coming from where. So if I make my calciums dots and my chlorines crosses, when there's a transfer, I know what's happening. So what I want you to do is to draw a dot and cross diagram showing the movement of electrons and the end charges. So have a go at that, pause the video, then check and see if you got it right. Okay, so the answer to this question is, well, number 1, I'm going to draw out calcium. Okay, I'm going to draw out the electronic structure for calcium. So it's it's in period 4, that means it's going to have 4 electron shells. So calcium 1, 2, 3, and 4. Right. So it's in group 2, so the outermost electron shell will have 2 electrons. So I'll just put those in 1, 2. I know the innermost can only have 2 maximum, so I'm going to put those in 1, 2. And all other electron shell can have a maximum of 8. So I'm going to put 8 in 1, 2, 3, 4, 5, 6, 7, 8. So I can't put any more on this ring. So I'm going to move on to the next ring. It's going to have 8, 1, 2, 3, 4, 5, 6, 7, 8. And so my electronic code, my electronic configuration for this is 2 on the first ring, 8 on the second, 8 on the third, and 2 on the fourth. That's 16, 17, 18, 19, 20, and there are 20 electrons and protons on calcium, so that's fine. But obviously these X's are representing the electrons. Now, if you remember and if you look at the formula that we did previously, we know that the end formula is going to be CaCl2, and that makes sense if you think about it, that we need 2 chlorines, and I'll show you why. Okay, I'll show you why exactly that makes sense. So chlorine is in group 7. I don't know why I wrote 1 there. It's in group 7 and period 3. So I'm gonna write chlorine here. It's in period 3, so it's gonna have 3 electron shells. So that's 1, 2, and 3. Right. Now what I'm gonna do is I'm gonna draw on. So it's on group 7, so I know on the outer shell it's gonna have 7. So I'll just draw on those 7. 1, 2, 3, 4, 5, 6, 7. I know on the inside you can have a maximum of 2, so there's 2 going on there, and this one's going to have a maximum of 8. So that's 4. Pair them up now, and 8. So there it is. So this configuration is 2, 8, and 7. 2, 8, 7. So 2 in the first ring, electron shell, 8 in the next electron shell, 7 in the next one. So now obviously this should have been dots. I've made the same thing again. I made the same mistake again, but I'll represent it with colors. So I've got this electron is going to move from the metal to the non-metal, right? So that's that. So now can you see that this has gone from 287 to 288? It's got a full outer shell. Now this has gone from 2882 to 2881. It's still not a full outer shell, so it still needs to get rid of this one other electron, which means that we need another chlorine. Do 1, 2, 3, 4, then pair them up. 5, 6, 7. I know the inside ring can have a maximum of 2, so I'm going to put 2 in there. 1, 2, and the next one is going to have 8, so that's going to be 1, 2, 3, 4, then pair them up. 5, 6, 7, 8. I feel like a gym instructor. So now you've got this electron here is going to move into the other chlorine, right? So this one's going to be here, and so I've got one here and one here. Now because this chlorine has gained an electron, how many electrons did it gain? It gained this one, so it's going to have a negative charge of 1. And this one has gained also 1 electron, so this is going to have a negative charge of 1, so that's just a negative. How many electrons did this calcium ion lose? How many electrons? It lost this one and this one, so it's kicked 2 naughty kids out, so it's going to be positive now by 2. And if you look, you've got -1, -1, and 2 plus. These will all cancel out, and that is what you should have. So you should have drawn this and then drawn it out separately, where they all have their own configuration of 288, 288, and this one, once you redraw this, it will have a configuration of 288. Every single thing within this ionic compound will have a full outer shell. So let's try another one. Now what we want to do is we want to combine magnesium with oxygen. Okay, so first what I want you guys to do, once I tell you what to do, just pause the video. I want you guys to combine magnesium and oxygen and write an overall formula for it. Okay, so magnesium is in group 2, oxygen is in group 6. I want you guys to work out the formula. So pause the video now and have a go. So what you should have got, guys and girls, is the following. You should have had magnesium, because it's in group 2, it's got 2 electrons in its outer shell. It's a metal, so it's going to give away those electrons. Once it chucks out those negative electrons, it's going to be positive by 2. Oxygen is in group 6, right? So how many electrons do we need in order to make it a full 8 outer shell? Well, we need 2 electrons. So if we've got 2 electrons and we add those to the oxygen, what charge will the oxygen have? It's going to have an O2 minus charge. Now what we're going to do to figure out the overall compound that's made is we're going to swap the numbers around. So this 2 from the oxygen is going to come down to the magnesium, and we're going to have Mg2. And this 2 is going to move over to the oxygen side, and we're going to have O2. Now because it's the same number, we can cancel this down, right, to have MgO, magnesium oxide. Now if we want to write an overall formula for this, we can do that. So the overall formula is going to be Mg plus O2. Remember, oxygen is diatomic, so it's always O2, is going to make MgO. And now we've got to ask ourselves, is it balanced? So I've got 1 magnesium, 1 magnesium. However, I've got 2 oxygens but only 1 oxygen. So what I can do here now is add a big 2 here. So now I've got 2 oxygens, but I've only got 2 magnesiums here but only 1 here. So to solve that, we just put a capital 2 here. So that's 2 magnesiums now, 2 magnesiums, 2 oxygens, 2 oxygens, and it's balanced. Happy days. So now the next task, once again guys, is make a cross and dot diagram for magnesium and oxygen. Now I'm going to give you the hint again that magnesium is in group 2. What periods are in? 1, 2, 3. So magnesium is group 2, period 3. And oxygen is in group 6. So oxygen is group 6, period 2. So have a go at that, guys. Period 3. So I'm going to do this here. Magnesium, group 2, period 3. And we need 3 rings because it's in period 3. 1, 2, and 3. Now it's in group 2, so I know I'm going to have 2 electrons on the outer shell, so I'm just going to put those in, 1 and 2. I know the inner shells can have a maximum of 2, so I'm going to put those in, 1, 2. And I know the next ring can have a maximum of 8, so I'll just put those in as well. So 1, 2, 3, 4. Then you pair them up, 5, 6, 7, 8. And now what are we doing it? We're doing it with oxygen. So I'm going to write oxygen over here, which is in group 6, period 2. So group 6, I'll make a note of that. Group 6, period 2. So it's in period 2. Now with oxygen I'm going to write ox, because otherwise I'll get confused with this circle. So it's in period 2, so I've got 1 circle, 1 electron shell, 2 electron shells. Now it's in group 6, so that means in the outermost shell I'm going to have 6 electrons. So let me just put those on. 1, 2, 3, 4. Then you pair them up, 5 and 6. And in the innermost shell, of course, we only have 2 maximum, so it's 1, 2. So what's going to happen here is remember the metal donates the electron, so I'm going to have this going here to donate that electron, and then I've got this electron coming here to donate that. And so I'm going to just plot these on, and of course this outer layer will disappear. So what that means for this oxygen is that it has now a full outer shell. So initially, to begin with, it had an electron shell of 2 6, so 2 in the first, 6 in the last one. Now it has 2 8. This one to begin with had 2 in the first, 8 in the next, and 2 in the last. And this has now become 2 8, so it now has a full outer shell, as you can see here. And this one also now has a full outer shell. Now this, how many electrons did it lose, guys? This magnesium, it lost 2 electrons. So if it's losing 2 negative charges, it's going to have an overall charge of 2 plus. The oxygen gained how many negative electrons? It gained 2. Therefore its overall charge will be 2 minus. And can you see this 2 plus and 2 minus will overall cancel each other out, and you've got a strong electrostatic force of attraction between the opposite charges. Overall it's going to be neutral, but those strong charges and opposite charges are going to make it have a high melting and boiling point. So I hope this has helped. Just get practicing, guys and girls and people of the world. I always knew I should be a rapper, but alas.